let's say you're trying to model a relationship between the number of rooms and the price of the house. Each dot represents a different house, the corresponding number of rooms, and the corresponding price. And we're trying to fit a line that predicts the price for different numbers of rooms. A linear regression output might look something like this. Where 1000 represents an imaginary house with 0 rooms, 200 represents the additional price for each additional room. So in a case of a 1-room house, it'll cost about 1200, and a 2-room house will cost about 1400. The error is the difference between our prediction line and the actual housing prices. Here's an error, for example. So why do we draw the line here versus say here or here or here? So we want to draw a line that minimizes the error. And then in our case, the error is the difference between our prediction and the actual value. Now some of the error is below our prediction, some is above, so we square it, just so that they don't cancel each other out. And then we have many errors. We have the error from this house, an error from this house, an error from this house. So we want to minimize the sum of the squared errors. Let's move on to assumptions of linear regression. So first assumption is linear relationship. Can you represent the relationship between your two data variables using a line? Versus, say you're predicting something like high versus low, in which case something like a logistic regression might be better. So again, linear relationship versus nonlinear relationship. Assumption 2, independence of the observations. Are these observations independent of each other? If you have a scenario where this is my house this year, this is my house next year, this is my house in 2 years, that is not independent because they're coming from the same house. Assumption 3, normality of the errors. Essentially, if you plot your errors on a histogram, does it look normal? Hopefully it centers around 0, and then some of the error will be above, and some of the error will be below. Fourth, homoscedasticity. Homoscedasticity. So, as you increase in whatever your x variable is, your rooms, the distribution of the errors is roughly the same in terms of like how spread out it is. So this is about homoscedasticity. Roughly, as you increase into x, the error is roughly around that much. Versus something that's hyperscedastic, your error might actually increase as you increase in x.